In this video, we are going to solve a problem based on the structure of silicates. Pyroxenes are a class of silicate minerals which exhibit a polymeric chain structure as shown below. They are given the pyroxene structure. In this structure, the dots represent silicon atom and the circles represent oxygen atoms. Its simplest repeat unit is. The given options are here. This question was asked in GATE exam 2010. In order to understand this, let us start with the simplest silicate, that is orthosilicate. Silicon belongs to carbon group. Similar to carbon, silicon also can form 4 sigma bonds. It will be sp3 hybridized and it can form 4 sigma bonds and the geometry will be tetrahedral. If you consider SiH4, silane, it will be similar to methane. The geometry will be similar to methane. But here I have SiO4. Instead of hydrogen, I attach oxygen. Oxygen valence is 2, but here I have only one bond, so the remaining is satisfied by minus charge. This is the simplest silicate. It is referred as orthosilicate. In this, I have one silicon atom and 4 oxygen atoms. Also, there are 4 minus charges. These 4 minus charges can be satisfied by some minerals. Suppose if I have some alkali metal like sodium, I have to attach 4 sodium atoms here. Similarly, potassium. Instead of that, I can go for alkaline earth metals also. For example, say calcium and magnesium. The valency of calcium and magnesium are 2. So if I attach 2 will be sufficient. For example, magnesium 2 SiO4. That will be one mineral or silicate. It is also possible to attach another orthosilicate to this. This oxygen atom may be attached to another silicon atom and what we get is pyrosilicate. This minus charge is attached with another silicon atom. Again, the geometry of these 2 silicon atoms will be tetrahedral. In this case, I have Si2 and O7. There are 6 minus charges. This is pyrosilicate. Suppose if you consider only one silicon atom, in that case it will be Si1 oxygen, there will be 3.5 oxygen atoms and there will be 3 minus charges. Suppose if you consider only half of this, but here oxygen we have 3.5. To make that into whole number, what we do, we go for Si2O7 6 minus. Here only one oxygen atom is shared by 2 silicon atoms. Suppose, say 2 oxygen atoms are shared. That is, in fact, if you extend in both the sides, what we get is pyroxene. Pyroxene is chain silicate. The previous 2 cases, I had only 2 silicon units, but here I have n number of silicon atoms. In that case, I can take this as the repeating monomeric unit. Here I have one silicon atom. There are 3 oxygen atoms. 1, 2. These 2 are not shared with other silicon atoms, so I can take them as such. These 2 oxygen atoms are shared by another silicon atom. So half of this oxygen atom belongs to this. Similarly, half of this belongs to this. So totally I have 3 oxygen atoms. There are 2 minus charges, so 2 minus. So this is the repeating unit in pyroxene. To represent this structure, we write like this. If you view this molecule through this axis, this oxygen will be in the middle. These three oxygen atoms will be at the corner of a triangle. Since the geometry is tetrahedral, these three oxygen atoms will be at the corners of a triangle. In fact, you will not be able to see silicon atom because you are viewing through this axis. Only oxygen atom will be visible to you. Silicon atom will be in the middle, so that's why we give silicon as a dot. This one can be written like this. Sorry, it is also possible to join like this. There is bond between silicon and oxygen atom. The structure of pyroxene has been given in the question itself. You can follow that. Say we have double chain. In pyroxene we have only single chain. Suppose say there is double chain. Let us consider double chain like this. This part, the upper one will form one chain, the lower one will form another chain. Each triangle represents the tetrahedral silicon unit. What will be the repeating unit in this case? Here I have two different types of tetrahedral unit. The first one is this one. Here only two oxygen atoms are shared. But in the next one, three atoms are shared. In this, three oxygen atoms are shared. Here only two are shared. So what I do, I consider this as well as this. In one tetrahedral, two oxygen atoms are shared. In another one, three oxygen atoms are shared. So I consider both. There will be two silicon atoms. What about oxygen atoms? This oxygen atom is shared by two tetrahedral units. So half of this will be included. Similarly, this is shared. This is shared. Sorry. Since I consider both, this can be considered as one. This is shared. Apart from that, I have four more oxygen atoms which belong to this unit. So totally I get 5.5 oxygen atoms. What about the charges? This is not shared. Because of that, there will be one minus charge on this oxygen. Similarly, there will be one minus charge on this oxygen and there will be one more minus charge on this oxygen. The oxygen atoms which are not shared by two tetrahedral units will have charges. So there will be three minus charges. Here I multiply by 2 so that I will get one number. What I get is 6 minus. It is also possible to get sheet-like structure. Here in one tetrahedral unit, 3 hydrogen atoms are shared. In another one, only 2 are shared. Suppose if you place one more chain here, in that case, in this also all the 3 oxygen atoms will be shared. They are referred as sheet silicates. Here 3 oxygen atoms will be shared. You can take any tetrahedral unit. 3 oxygen atoms will be shared to give sheet-like silicate. Let us consider this tetrahedral unit. The oxygen atom which is in the middle, that is not shared with another tetrahedral unit. These 3 are shared. To find out the repeating unit, I take the silicon atom. In this I have one silicon atom And there are 2.5 oxygen atoms. This oxygen belongs to this tetrahedral unit. So 1 and these 3, they are shared. So 3 int of 1.5. So totally I get this. What about the minus charge? Here I have one oxygen atom that is not shared, so I will get like this. To get whole number, I multiply by 2, Si2, O5 and 2 minus, this is what I get. For sheet silicate, the repeating unit will be Si2, O5, 2 minus. Now we can go through the given options. This is for orthosilicate. This is for pyroxene. So this is the correct answer. This one is for double chain silicate. This one is for sheet silicate. So the correct answer is SiO3 2 minus. Sorry, this is not for sheet silicate. Here Si2O7 6 minus. So this is for pyrosilicate.